Can you guess which Counter-Strike map this is? Or this? Or this? Well, since I'm an expert at solving problems that nobody has, I made an AI to do just that. But to get there, I had to solve some interesting problems. For any machine learning task, we need data, and preferably lots of it. So I went onto each CS2 map and took 10,000 screenshots. But as a programmer, of course I didn't do it manually. In Counter-Strike, you can access the developer console and execute commands to control the game. We will need two commands in particular: setPos, which takes an X, Y and Z coordinate and places your character at that location, and setAng, which takes pitch, yaw and roll values to set your viewing angles at the current location. Here you can see the command in action. When you type getPos, the game gives you setPos and setAng parameters for your current location and viewing direction. And since it's possible to execute commands by loading a config file, my first thought was to just create one with a Python script. To do so, I first had to find the map boundary coordinates by flying into the corners. For example, on Dust 2, the playable area spans from about -2400, -1200, 500 to 1600, 3200 and -130. In this bounding cube, I can use Python to sample 10,000 random positions and view angles and write them into a file in the correct format. Now I just have to execute my script in game and... So I thought, alright, I'll just split it up into multiple scripts and load them one after another. I'll just have to stay under the 1 MB per file limit. To update the code, I just had to set a limit for how many commands per file I want. And on the last command of each file, it has to execute the next one. We now have a set of reasonably sized files with 1000 commands each. And I just have to execute it in Counter-Strike and...
Alright, top 8 answers on the board, ladies. This is a fill in the blank.
What are CS2 console errors nobody has ever seen before? Warning, command buffer full, ignoring.
They're gonna play.
Oh well. I guess it doesn't matter to me if I just make each file even smaller, since I don't care how many config files are being generated. Through some testing, I figured out that 100 commands per file is a number that works consistently. And that actually worked. Here you can see me teleporting through the map with one key only. To actually take screenshots after each teleport, I bound the commands to F12, which automatically takes a screenshot in-game. With PyAutoGUI, I wrote a loop to automatically press the F12 key, and now I just had to wait until I have a decent amount of screenshots.
How, you ask? Like this. And there you have it.
An hour later, I actually had over 10,000 images. Skimming through them, many of them looked really good, but a lot were taken from inside walls or high in the sky. At first I was worried that this might be an issue, but I assumed that the neural net I was going to train is not going to care. It will just learn patterns of the map, and as an added benefit, it will still work when flying through the walls with no clip. After repeating this for each map, I now had over 100,000 CS2 screenshots in neatly labeled folders, which gets us to the fun part, training the AI. If you have any experience in training image classifiers, you know that you can use a wide array of network architectures to get you to your goal. For the most part, it doesn't even matter that much which model parameters you pick. In many domains, however, this one included, we can leverage pre-trained models that are already good at picking up certain patterns. This way, we can save a lot of training time and may even get better results than if we trained on just our data, due to transfer learning. Setting up an image classifier model is extremely simple these days, so there is no better time to get into machine learning. Basically, PyTorch handles everything that's complicated for you. For the base model, I decided on ResNet 50, since it offers a decent trade-off between quality and model size, which impacts training and inference speed. To set up the model, you just have to install PyTorch and use the existing ResNet function like so. It will automatically download the ResNet model weights. Then you just have to add a linear layer on top to match your classes. So basically your model looks like this. Starting the training, I split the dataset into training, validation and test images. If you're new to AI, this is extremely important and needs to happen on every supervised model training. Imagine you're a math teacher and gave all your students the exact questions and answers that would appear on the next exam. They wouldn't try to understand the math, they would just learn the results by heart. Neural networks can also have this issue, and it's called overfitting. To find out if this is happening, we regularly let it predict images from the validation set during training, to see if the performance on new data is actually getting better over time. The images from the validation set have not been used to update the model weights, they are just used for verification. The model does not learn from them. The final portion of images, our 10% test set, is basically reserved for the exact same thing, after training has completed. Kind of like a final exam. If our model performs well on the test set, we can more confidently say that it will also work on new data. So all that's left to do is start training. I decided on 100 epochs, with an early stop if no improvement to the validation accuracy has been achieved in 10 consecutive epochs. I hit the run button and it seems that each epoch takes around 15 minutes to train, so it's best to let it run overnight. Sadly, the original footage got corrupted, so you're watching a rerun on a small subset of the original training data. And while the training is running, since this is my first video, please subscribe if you liked it so far. I'm planning on a lot more game-related AI content in the future. When I checked the progress next morning, I was delighted to see the test accuracy was over 99%. This was much higher than expected, as there were so many images with just sky and barely any detail. I quickly wrote some code to test the model in-game. It basically works the same as a training code, it just doesn't update the weights after guessing the input image. I can now fly through maps and see the guesses of my model. All I can say is it performs extremely well. When seeing any discernible portion of the map, it is basically 100% sure which map it is. But even for extremely close-up shots, it is correct very often. Here are some more screenshots of CS maps. I only picked common positions that you see in normal play. Write your predictions in the comments and see which ones you got right. Oh, and right before we end the video, a CS2 update came out which changed the layout of Vertigo. Let's test the AI if it can still detect the map without seeing any of the changes during training. And it seems to work perfectly. So the model didn't just learn the training data by heart, it learned what it means for a map to be Vertigo. If you made it until here, thank you so much for watching. If you like this kind of content, consider subscribing, since I will work on more AI projects in the future.